Okay, let's just jump right in with a question. What if I told you that there's an invisible, man-made chemical inside the body of pretty much every single person listening right now? Now, really, that's not an exaggeration. According to the CDC, we're talking about a whopping 97% of the American population. It's in your blood, it's in my blood, it's just there. So, what is this stuff? And how on earth did it get there? Well, today we are diving deep into the world of PFAS. You've probably heard of them as forever chemicals. We're going to explore the science, the history, and the massive, high-stakes battle to clean up a chemical that was literally designed to never, ever go away. All right, so here's our roadmap. We're going to start at the very beginning with its wild, secret origin story. Then we'll track how it's spread all over the globe. After that, we have to look at the serious toll it's taking on our health. And then, and this is the crucial part, we'll get into how science is finally fighting back and what the path forward actually looks like. You know, you might think this story starts in a kitchen with a nonstick pan, but it doesn't. It starts in a top-secret lab during World War II as part of one of the most ambitious and, frankly, terrifying projects in human history. That's right. PFAS were a byproduct of the Manhattan Project. The scientists building the atomic bomb had a huge problem. They needed something that could handle the incredibly corrosive uranium gas they were using. They needed a material that was almost supernaturally stable and unreactive. So what's the secret sauce? Why do we call them forever chemicals? It all comes down to one thing, the carbon-fluorine bond. Now, this isn't just a strong chemical bond, it is the single strongest bond in all of organic chemistry. Think of it like a chemical fortress, locked so tight that nothing in nature, not a single microbe or enzyme, has the key to break it apart. It was engineered to be indestructible. So, after the war, companies like DuPont and 3M looked at this incredible chemistry and saw dollar signs. This military-grade invention became the miracle behind Teflon nonstick pans, Scotchgard stain repellent, and even those high-tech foams firefighters used to put out jet fuel fires. For decades, it really seemed too good to be true. And, well, it turned out it was too good to be true. Because the very thing that made these chemicals so magical, their indestructibility, is the exact same thing that now makes them a global threat. So how did this stuff get everywhere? How does it get from a factory into our bodies? It's a process called bioaccumulation, and it's like climbing a toxic ladder. It starts when PFAS get into the water. From there, tiny little organisms like algae absorb it. Then small fish eat the algae. Bigger fish eat the small fish. And the chemicals keep moving up the food chain. And at every single step, the concentration gets higher. And guess who's sitting right at the top of that food chain? Yep, we are. The scale of this is it's mind-boggling. Scientists have found these chemicals in rainwater on remote Himalayan mountains. They found them in organisms living in the deepest trenches of the ocean. And as we already know, they found them in nearly all human blood. There's literally nowhere left on Earth they haven't touched.
Okay, so this brings us to the really important question. What's the biological price we're paying for all this convenience? What does having these forever chemicals floating around inside our bodies actually do to us?
Here's the problem. On a molecular level, PFAS are basically imposters. They have a shape that's incredibly similar to the fatty acids our bodies need to function. So our cells get tricked. They let these PFAS in, and once they're inside, they start to wreak havoc on our endocrine system. You know, the system that regulates all of our hormones.
And the consequences of that disruption are pretty severe. Decades of research have drawn direct lines between PFAS exposure and a truly horrifying list of health problems. Things like kidney and testicular cancer, thyroid disease, a weakened immune system, and even developmental issues in infants.
And this is really the bottom line, and the CDC puts it bluntly, the whole conversation has shifted. It's not a question of if you've been exposed anymore. The only question now is how much has built up inside you over the years.
It's a grim picture, I know, but here's where the story takes a turn. Science created this problem, but now, for the first time, science is coming up with real ways to uncreate it. So let's talk about the scientific fight back. For years, our attempts to get rid of PFAS were, frankly, a disaster. We'd bury the stuff in landfills, and it would just leak right into the groundwater. So then we tried to burn it, but unless you got the incinerator incredibly hot, you just sprayed the chemicals into the air. We were actually making the problem worse. But now, scientists are developing some incredible new weapons.
One method, called supercritical water oxidation, uses insane amounts of heat and pressure to literally snap those tough CF bonds. Then there's this really clever breakthrough from Northwestern University. It uses common, cheap chemicals to attack a molecular Achilles heel on the PFAS molecule, which makes the whole thing just unravel. And other teams are using plasma and electricity to create these little reactive agents that just hunt down and destroy PFAS in water. These aren't just small improvements, these are potential game changers.
Having these new technologies is fantastic, but it's only one piece of the puzzle. At the same time, there's another race happening, a race for regulation and, finally, for some corporate reckoning.
And just look at this timeline. It shows you what a long, painful road this has been. We have internal company memos showing that places like 3M and DuPont knew about the toxicity of these chemicals way back in the 1970s. But it took until the 2010s, that's a 40-year gap, for the lawsuits and the massive public settlements to finally force their hand.
So what's the new regulatory strategy? Well, governments are starting to adopt something called the essential use concept. It's actually pretty simple. Instead of trying to ban all 12,000 types of PFAS at once, they're just asking, is this use absolutely critical for society? So PFAS in a life-saving medical device? Probably essential. PFAS in your pizza box or your makeup? Yeah, not so much. And those non-essential uses are finally being phased out. All of this leads us to a pretty clear 3-step plan for the future. Step 1. We have to filter our drinking water to stop more of the stuff from getting into us right now. Step 2. We use these incredible new technologies to destroy the huge stockpiles of PFAS that are already out there. And step 3, we innovate and we replace these chemicals with safer materials so we never, ever repeat this mistake again.
The whole era of PFAS has been this profound and really painful lesson in unintended consequences. We created a miracle of modern chemistry that became a slow-motion biological curse. And it leaves all of us with one central defining question for our time. Science was the creator of the forever chemical. Can it now, finally, become its executioner?